So, looking ahead to this week, today we'll do day 2 of 5.4. We'll do one more style of factoring, then we'll jump into solving. Tomorrow, on your off day, you'll have a formative in the MRC. Wednesday, we'll finish up solving. Thursday, we'll start dividing. Okay? So, that's where we're at right now. And then, still looking ahead to next week, Wednesday, being quiz day. Okay? Okay? So, on Friday, I gave you a checklist, a 4-step checklist for factoring. First step was greatest common factor. Second step was difference of perfect squares. Third step was trinomials. Fourth step was cubics. Okay? Fifth step now, adding step 5 into the factoring checklist, is factoring by grouping. The reason I didn't bring it in to play on Friday is because it only happens in the rare occasion that your polynomial function is, or your polynomial for that matter, is bigger than 4 terms. And it's got to be an even amount of terms. Okay? It helps if you've got 4 or 6 or 8 or 10 terms. Okay? And really, all it is it is just 3 GCFs. Okay? That's all you're doing, is 3 greatest common factors. All right? So, let's do one. Let's dive right in. So the first thing that I'm going to do, so you can skip the list if you count 4 or more terms in your polynomial. Okay? Because the only one that deals with 4 terms is grouping. Okay? So you can go right to grouping if you got 4 or more terms. So, first thing I do is I am going to take and I am going to divide the polynomial in half. So since there are 4 terms, I'm going to put 2 terms on either side. Provided it's in standard order. Okay. Then I am going to GCF the left side. What is the greatest common factor there? No. X squared. Right? Okay. What's left over? X minus 7. Then I am going to GCF the right side. What's the greatest common factor there? 8. What's left over? Then I am going to GCF that. What's the greatest common factor between those 2 terms? green term and the red term. What shows up in both? X minus 7 shows up in both. So I can pull out an x minus 7. What's left over? X squared plus 8. Can x squared plus 8 be factored even more? Nope, can't be. So that's my answer. Okay. GCF the left half, GCF the right half, and hopefully when you do that, you come up with, you should see in that parentheses, when you produce those, in that parentheses should be the same thing for you at the end. Okay? Try that one. So I start by GCFing the left side. I can pull out a 9t squared. Leaves me with 3t plus 5. So I want my parentheses to be 3t plus 5. So I'm looking at the right side then. Well, if I yank out a -1, then that leaves me with 3t plus 5. Which is good, because then I can pull out a 3t plus 5. And that leaves me with 9t squared minus 1. 9t squared is a perfect square. 1 is a perfect square. And it's a subtraction sign. So I can factor completely all the way down to 3t plus 5. 3t minus 1. 3t plus 1. Okay. Try that one. Left side, take out an x squared, leaves me with 2x plus 1. Right side, take out a plus 1, leaves me with 2x plus 1. So if I can't factor anything, I got to factor out a 1. Because I have to do the GCF 3 times. Okay? Then, x squared plus 1, you want to factor that to be x minus 1, x plus 1, but it's not because it's not subtraction. Okay? Questions on that? Fantastic. Let's be done with that, and let's move on to solving. Okay? The fundamental theorem of algebra states that the degree, which, refresh my memory, what's the degree of a polynomial? What's the degree of a polynomial? In your notes.
The power is raised to?
Even more than that. Even more than that. Because it might not always be written in standard form. What's the degree of a polynomial. I want to say it was in 5.2.
Power of the polynomial?
Yep, it's the biggest power, biggest exponent. Okay, degree's the biggest exponent. Okay, can't go with first because it might not be written in standard form. Because we might have an equation and it might be all jumbled around. Okay, so I can't go with first. I can't go with just an exponent because there's 3 exponents in that problem. Okay, you only see 2, but there really is a third one where it's just 1. Okay, so I can't just say exponent and I can't just say first exponent. I have to say biggest exponent. Okay? So the degree of a polynomial is the biggest exponent. Okay? What the fundamental theorem of algebra says is that the degree of a polynomial tells us how many answers, solutions, x-intercepts, crosses of the x-axis, whatever you want to call it, that tells us how many of those there are. So in this particular example that we're about to do, how many answers should we get in the end? What's the degree of that one? 5. So I should get 5 answers. Okay? Biggest exponent is 5. I got to get 5 answers. What if I only get 1? You're wrong. Okay? Until you get 5. Now, some of those 5 might get kicked out, or they might be repeated. Okay? And that's fine. Okay? That's fine. We don't have to write down the repeats. Okay? But we still count them. Right? So how we go about doing this is, and today we're only going to be asked to find real solutions. Next week, we'll get into imaginary numbers, and then we'll be able to just say, solve these. Okay? But until we get there, we're just going to tap the brakes and just do real ones. Okay? So, step number 1, you want to get it equal to 0. So in this particular case, I would be adding 36x to both sides. So that gets me 4x to the 5th minus 40x cubed plus 36x equal to 0. So step number 1 is done. Step number 2, we are going to factor that completely. So let's run the checklist. Step number 1 was what?
Set 2 equals 0.
No. Checklist for factoring. Different checklist now. GCF. Can I GCF it? Yeah? What? 4x. What's left over? X to the 4th. Now what? Now negative 10x squared. And? No. Plus 9? So I've GCF'd it. Now I got to look inside that new set of parentheses. Is that a difference of perfect squares, which was number 2 on our checklist? Is that a difference of perfect squares? No. Is it a trinomial? Yes. So can it be trinomalized? It can be. Okay. What? What two numbers multiply together to be positive 9 and add to be negative 10? Negative 9 and negative 1. So this is x squared minus 9 and x squared minus 1. Right?
Yes.
Okay. Now I got 2 more sets of parentheses. So I got to go back. Item number 2. Is x squared minus 9 a difference of perfect squares? Yeah, it is. Is x squared minus 1 a difference of perfect squares? Yeah, it is. So this ends up factoring completely all the way down to 4x times x minus 3 times x plus 3 times x minus 1 times x plus 1, and all of that is equal to 0. So now that I've factored it completely, I'm going to set my factors equal to 0, and I'm going to solve it. So my first factor is 4x. I set that equal to 0. X minus 3 equals 0. X plus 3 equals 0. X minus 1 equals 0. X plus 1 equals 0. First one, x is equal to 0. Second one, x is equal to 3. Third one, x is equal to negative 3. Fourth one, last one. How many answers did we get? How many answers were we supposed to get? 5, right? Yeah. So we got them all. Okay? Now, how you write your answers is up to you as long as I can see them. If you leave them like that, that's fine. If you write them as a list, that's fine. If you use pluses and minuses, that's fine. Okay? But I just got to be able to see what your answers are. Okay? With me? All right. Try it. Find me all the real solutions. Guessing we all did this. Yes? Guessing we all did this. And that's where I'm guessing we got stuck. Have I factored it completely? Yep, I factored it completely. So now what do I have to do?
Make it equal to 0.
Set my factors equal to 0. Take the square root here, right? Right? Okay. Square root of a negative. What do I got to bring into play? I, right? Okay. All right. And does that make it real or imaginary? Imaginary. Okay. Other thing I got to bring into play is plus or minus. Now, this question asked me to find the real solutions. This is not real, so therefore, yes, it's a solution, but it's not one that I want to give in the end. Okay? So I have two solutions there, but they're just not real. So there's my 4 total solutions, but only 2 of them are real. The other 2 are imaginary, complex, if you will. Okay? Questions on that? Try that one. Can I GCF the whole thing? No, right? Okay. Is it a difference of perfect squares? Nope. Trinomial? Nope. Cubic? It is a cubic, but it's not a sum or difference of the cubes, right? Okay. So what does that leave me?
Just this, right?
What?
Just that. You just need to like equal to 0.
No. There's one other method. Grouping. We just learned it 10 minutes ago. Okay? Alright? So this is a grouping one. Gives me 2 imaginary solutions and 1 real solution. Since I only wanted the real solution, -3 is all that I need to give. I have 3 total solutions there, but 2 of them are imaginary. homework for tonight will be due next Monday. There will be a formative tomorrow in the Resource Center. Okay. Yeah, that's all I got.